Well, now we've arrived at the end of the course, and let me first say that I hope you enjoyed the course. I hope also you persisted and did the exercises. And that's the way to get really the insight. It's not just listening, you have to do things to really understand deeply what we're talking about. And if you're a student, which is one of the audiences, I hope that this course shows you the interest of the area, programming languages, how dynamic it is, and the kind of mixture of practical and conceptual thinking we're doing. So the whole question of how to marry power and simplicity is as important as ever. So things are progressing, but we still have a long ways to go. If you're a developer, you already have quite a bit of experience. So I hope you were able to hold your interest at least part of the way and give you some insights, some new insights perhaps, or combine insights maybe in novel ways. For example, for the semantics, for the concurrency, and for the interrelationships among the paradigms. So then both to students and to developers, I say, please send me your feedback, send me all the constructive comments that you have. We really would appreciate it. What you think about different course, concrete comments, books, things, whatever, any kind of comment, we really, really appreciate it. And we'll try to improve the course in the future. And a final point then is we are using and developing Oz and Mozart 2, the system of this course, for both education and research in ongoing projects. And we're doing a number of things with it. We are still developing the basic system, but we are extending it for distributed programming. For example, large-scale synchronization-free programming, also for constrained programming. And as usual, in such projects, we are woefully underfunded, and so we can use all the help we can get. So if you're interested, you can join our community. Now we're doing both research stuff and application development, systems development. So any kind of talent is welcome. Just make yourself known on the Mozart users mailing list. So for further study, in this course, we've only scratched the surface. I've tried to give you as much information as possible, well factored and digested, so you go as deep as possible, but still, it's a huge area, so it's only a very small part that I've given you. One thing that you can look at is the paradigms poster. This is a generalization of the paradigms diagram that we saw a little while ago, with many paradigms with explanations. Also, I have compiled a list of some reference works. This is definitely not a definitive or complete list. It is idiosyncratic. It is the books that I have found useful for understanding, for designing, for building. Not all these are programming language specific, but all will help you in thinking the kinds of things that you have to do when designing and implementing paradigms and languages. I've also made an effort to pick works that pass the test of time. Some of them are fairly old, but it's not because things are old that they're useless. So that's one of the common mistakes in the computing area, because things move so fast. People think that the old stuff is out of date, but many old things are not out of date. So here's a short bibliography. Here's a couple of these I want to give comments on. So of course, Structure and Interpretation of Computer Programs is a classic. It has huge amount of insight. A second book on the innovation on TRIZ also surprisingly has enormous insight. It has concepts in there such as technical contradictions, which are very important whenever you want to innovate. Then there's the book on Erlang, of course, the classic concurrent programming in Erlang. Mythical Man Month about software engineering, you have to know that. And then there's the work on Ozma, so adding deterministic data flow to Scala. There's concurrent programming in Java. There is Bertrand Meyer's classic book on object-oriented programming. There's Martin Odersky's book on Scala. There is Okasaki's book on purely functional data structures, which just shows you really the power that you get from lazy execution in functional programming. Then if you want to learn about types, and you think it's kind of an opaque area, you really want to understand things, Benjamin Pierce's book is the way to go. There's also Sterling and Shapiro's book on Prolog if you want to understand how logic programmers think. Now, Prolog is old, but it's worthwhile understanding that. Then, of course, there's the works that are directly related to the course here, the CTM book and some more recent articles. And finally, Weinberg's book on general systems thinking is also a very interesting book when you want to see how computer science is helping advance complex systems design.